Okay. The timing analysis is nothing but in the chip designing. So it's determining of the timing constraints, whatever you are interfacing in the design. Suppose consider that what we do in the timing analysis. So whenever, like, suppose you are, if you like take an example of this phone, smartphone. If you want to use the any app, you will click on the app within a fraction of second, like there will be a timing estimation. Within amount of that time, the app has to open. So for that, the data has to reach, the signal has to reach, right? Similarly, let's take an example in the human being. Whenever you want to move, the signal has to send to the brain. That time only, like then only you will do the some functionality, right? Nothing but like in the, it will take that time. Similarly, in the design, whenever you are sending the data, within that amount of data, the data has to reach. The timing analysis is nothing but like whatever you are taking the frequency, right? Whenever you are talking about the like buying the any smartphones or any like electronic gadgets, you will check what is the frequency, right? Nothing but you will check for the speed. So all that constraints, like the people will be talking like in which nanometer, like in which processor, like which processor is having like a which frequency, like mega 800 megahertz, 950 megahertz, 1 gigahertz, right? Those are nothing but your timing specification. So in the timing analysis, we do have the two types of timing analysis. One will be the dynamic and other one will be the static timing analysis. In the dynamic timing analysis, we will check the functionality as well as the timing for all the circuits. In the design, whatever you have the circuits designed, right, it will check for the functionality as well as the timing for each and everything. Whereas the static, it will check only for the static. Sorry, it will check only for the timing. It won't check for the functionality. So since it is not checking for any functionality of the circuits, it won't take much time. It will be easier and it will be faster. Whereas the dynamic, it will check for both functionality as well as the timing. So that's why it will take a more time. So it has to check for the functionality, right? It needs some another vectors, nothing but another kind of inputs it needs. Whereas the static, it is a vectorless. It needs the input, but it is not, but for the functionality, it is not checking for any functionality, right? It will be the vectorless. It needs only the input for the timing analysis. So the main difference between the dynamic and the static timing analysis is that dynamic timing analysis, it will check for the functionality as well as the timing. So it needs the inputs. It will be slower and it will be the complex, but accuracy wise, it is more accuracy. Whereas the static timing analysis, what it is doing, it is checking only for the timing, not for the functionality. So it is a vectorless and it is faster. Why? Because it is checking only for the timing. And it is compared to, it will be accurate in the timing, but compared to the dynamic, it is not that much accurate. So this is a main fundamental of the timing analysis. So we are not checking any for the DTA, nothing but dynamic. We will only go for the static timing analysis. For the PD engineer, it will be the very important. A stage very important. Why? Because in every stage you will be checking for the timing. So in that, what will be the, this is just what we have discussed. So the advantages of the static over the dynamic, it will be the fast and it won't require any input, nothing but it will be the vectorless. Since it is checking only for the like timing, right, it will be suitable for the large designs. Whereas the DTA, right, it won't suits. Why? Because if we have like 45 million, 50 millions of instances, it has to check for each and everything, like for all 50 million instances, it has to check the timing as well as the functionality. So it will be not suitable for the larger design. So next we'll go to the what are the inputs and the outputs of the STA. Any doubts in the basics like DTA and the STA? Guys, any doubts?
No, ma'am.
Guys, if you're not understanding, please let me know. Why? Because this is a very, very important concept. The inputs you will be needing the SPEF. It will be given from the which team? It will be given from the PD team. And the gate level netlist, it will be given from the front end like synthesis. And the SDC, it's also given from the synthesis team like front end. And the library and the SDF. Sometimes SDF it will be required, sometimes it won't require. And the left you need. Apart from this, you need the SPEF, DEF, LEF, gate level netlist, SDC, and the timing library. The output will be the timing reports as well as the timing window. So we will be have we will get the like once you run the PT, right, you will get the reports, timing reports. So there you can see that whether it is the timing has met or the violated. If it is violated, you have to fix that. So the inputs is nothing but the library, SDC, LEF, DEF, SPEF. So this the SPEF is generated when there is a separate tool for the to generate the SPEF. It's a star extraction tool. So once the PD guys will do, right, it is depends on the company how the flow it will be. There will be in the some company there will be a separate team will be there for the SPEF extraction. In a some of the companies like as we are doing, we will be generating the SPEF in the flow itself. So the PD guys will generate the SPEF, the front end guys will give the net list, the same the SDC also given by the synthesis, the library is given from the technology team, nothing but it will be from the tech. And the left and the def is generated from the PD. So we'll see one by one what are the inputs, what it contains. The first one will be the gate level netlist. Sometimes it will be given in the VGS or in the .v format. Okay. So the gate level netlist, it contains all the information of your design, how the connection has done. Suppose consider that the AND gate is connected to the, I'll show the netlist in the design. Don't worry. So it will be given from the synthesis team. Suppose consider that AND gate is connected to the OR gate is connected to the MUX is connected to the flop. So this connection has to given somewhere, right? So this will be given from the gate level netlist. In your design, you will be having a n number of like cells, nothing but your flops, memories, everything. It will be included, but it has to connect, right? Suppose consider the XOR gate. If you consider the XOR gate, what are the gates you need for the XOR gate? What are all the gates you guys need in order to form the XOR gate? Guys,
Sorry,
guys,
William.
XOR gate, what all the gates you guys need?
NAND.
NAND,
No, OR gate and
OR gate and
AND gate.
Okay, then write down the expression of XOR gate here. Guys, in the chat box, write down the expression of the XOR gate.
or and not.
Write down the expression.
Ma'am, y equals to A bar B plus AB bar.
What about others? So if we consider the XOR gate here, right? You guys have written the expression. So what all the gates you need to implement the XOR gate?
NOT gate, AND gate, and OR gate.
Yeah. You need the NOT gate, AND gate, and the OR gate. It has to connect, right? The tool don't know how to connect, but you have to convey the tool to connect in the this format. Suppose consider that there will be a input to the NOT gate as a and there will be a AND gate. That NOT gate output should connect to the AND gate input, and the similarly the another NOT gate should connect to the B, and that to connect to the OR gate. These connections will be mentioned in the netlist. So whatever in the designs you have, right, it will be written in the, it will be given in the netlist, gate level netlist. So it will give all the things. And the netlist, whatever the netlist, right, it will be the STA will be doing in the two different stages. One will be the before PD and one will be the after PD. So when the STA is doing like before the PD, right, it's a pre-layout STA. Once at the sign off stage in the post, like post layout, nothing but after doing the PD, also the STA will be done. That's a post layout STA. When you are giving the accurate timing, right, it is in the post layout STA. For the estimation purpose, we will be doing in the pre layout STA. So if we take the pre layout STA, right, whatever the SPAF, everything will be there, right, it is not the accurate thing, it's the estimated value that will be given to the tool. Next will be the SDC. SDC is nothing but the synopsis design constraints. So the STC is, oh, in the STC, it will be contain the information of the clocks, your DRVs, nothing but the input transition, capacitance, output load, what will be the input delay, output delay, your setup time, hold time, all the timing exceptions, all the timing related like case and set case analysis, disable, whatever it will be doing, right? It is doing it on the synopsis design constraints. So in that synopsis design constraint, it is like if you have the design for that, you will be having the clocks. That clocks has to define somewhere. That clocks are defined in the SDC file. So the clock definitions, in the clocks, you will be having a generated clocks, virtual clocks, that will be defined in the SDC itself. And you will be having the DRCs or the DRVs, nothing but the transition time, your capacitance, as well as the load. And you will be having the input delay, output delay, and the timing exceptions. The timing exceptions are nothing but the false path, multi-cycle path, max path, and the mean path. Apart from this, you will be having the other timing constraints. So next, these all are the commands which you can see. How the, with the help of these commands only, you will be defining it in the file. In the interview, they will ask these commands. How will you create the clock? How will you generate the clock? How will you set the input delay, output delay, D rates, transition time? How will you set the false path, multi-cycle path, half cycle path, max delay, min delay, in setup time, hold time? All the commands, all these will be defined with the help of the commands. And these commands definitely they will ask in the interview. So please be aware of the commands. Next will be the Liberty file or the library. In the library, you will be having it will be given from the technology team. So the Liberty file, which will contain the information of the timing, PVT corners, and the DRVs. So what it contains, whatever you are having the cell, right? That particular cell, it should have the your transition time as well as the load. So based upon the transition time and the load, it will take the delay. Nothing but as of now, just remember that there will be a delay table and for the each and particular of the cells. So the Liberty file will contain the information of the timing, functionality, PVT corners. PVT is nothing but the process voltage temperature, and the input capacitance, output capacitance, power consumption, and the functionality of the cells. So all it will contain in the Liberty file. The output will be the timing report. So we'll see in the tool. Okay. I will show the inputs and the outputs of the inputs. So you guys need to, today you guys have to go through all the inputs and then understand it. If you have any doubts, and then we'll discuss tomorrow. Here, just go to the PD underscore SB. In this one, go through the labs PT. In this one, go to the PT. Before that, I'll remove this file. Go to the PT folder. In that, I think A reference, design data. Okay, here also it's there, and we'll see. Let's see. If it is in the DB, right, you can't open that. CD scripts. This is not required as of now. Okay, let's go for Orchid outlet. It is present. Before going also, we'll see that Orchid design is present or not. Let me check about the STC also. Okay, fine. There might be the Orca where it is. Go to reference only. See up to date. Message. It is not the scripts. Okay. I think yes, this is here only. It says, let me check. PD blocks. It is not there. Okay, wait. Here it is there. Max STC. Max point. But here it is there, but it is not in a proper manner. If it will be mm, someone has removed or what? Okay, here it is there. I'll show multiple so that I can. Okay. First, this will be the net list. Just take like whenever you will be having the design, right? So for that, you will be having the inputs like a net list, left, def, SDC, and then library file. So in the library, in the design, right, like netlist, you will be having the connection. Suppose consider that you will be first, you will be defining the inputs and the outputs. So once I'll take the functionality, suppose consider that these all are the cells, like whatever the instances, right? U85 is nothing but it's an instance. So the A1, here you can see that dot A1, it means that particular instance A1 input, it will be connected to the N6987. N6987 is nothing but it's a net. It's a wire. Here it will be, because this is a what is wire, it means that the output of the one cell which is connecting to the input of the another cell, that is nothing but a wire. It will be defined, so it will be connected. So here this, for XOR, nothing but this instance name, this will be the instance name. You can give it anything. The top level engineers, it will be given like a U118, U185. They will be given. That will be the instance name. So this Z is connected to the Z of that instance is connected to the N6113. And for the another input A2 is connected to the N6369. This is how the connection will be doing. I'll just show one more thing. Suppose you can see that this is a buffer. This will be the buffer. Okay. So for that buffer, what it is doing, the input is connecting to the somewhere the output, the result, right? The result is the output of some cells that is connected to the input of this buffer. The output is giving to the result of 10. Nothing but if you take the one buffer here, the input is I, output is Z. The input is coming from some other net. Suppose consider that here the input is coming from the result 10 AST. Let's find whether it is present here or not. So here you can see that this is the output of this cell. This is connected to the buffer. See here. That is the output. That is a Q, right? Q. Now it is a I. Nothing but that output is connected to this buffer I. So whatever the instances which are present in the cell, nothing but sorry, in your design, it will be connecting in this manner. All the connections will be given in the netlist because the tool don't know that which cell has to where and which cell has to connect to which cell. It don't know the connection. So for that, when it is read the netlist, it will connect, it will do the all the connection by itself. Any doubt in the netlist? Any doubt in the netlist? The simple thing, the netlist will have the all the information of the connectivity of the design. Any doubt? Guys, any doubt? If you don't have then doubt, I have a doubt, I'll ask the question. You guys don't have the doubt, right? Hurry guys, speak up.
I mean, ma'am, I had doubt like how we got that inputs, outputs, everything without.
Without?
I mean, how can you design that? It is a inner design or you already designed that one?
That it is designed by the architecture. It is not like in the PD, right? In the VLSI, there won't be any one team. It will be having the separate team. The RTA guys will do, right? I will
Okay.
explain once the PD design comes. See, once the customer comes to you and he will ask for the design, I need this kind of chip. So for that, what we'll do first, we'll take the all the customer requirements. We'll do all the specification. So after that, the architecture will be done for that particular chip. Once the architecture is done, it will be divided into a sub architecture. Nothing but it called as a micro architecture. So the whole chip is divided into the small parts. So
Okay.
once it is done, the designer will get to know that what all the things they need. After that, the RTL designer will write a code like how the design will be done. Suppose consider that take the full adder. If we take the full adder, we know that what is the sum and what is the carry. It's nothing but we are designing a small circuit, right? The full adder will know like we need the XOR and we need the AND gate. Once we design it, we'll get the full adder. Similarly, the top level engineers, nothing but those will be working on the chip level, right? Those guys will make the design and they will get to know that what all the designs like what all the circuits they need. So they will do the circuits and they will make the interconnection of that one. So once it is done, right, it will generate that, it will go to the verification team. They will verify the design. After that, it will go to the synthesis team. So once that code will be generated, right, the simplified netlist will be generated. So whatever you asked, right, that code, it will be written from the top level engineers. So they will get to know that.
Okay.
Okay.
Thank you.
Yeah. Any other doubts? No doubts? Okay. Then we'll go another input called a SDC file. In the SDC file, it will be here you can see that there are three clocks that defined in your file. So you will get to know that how many clocks are there in your design and what is the clock period of that particular clocks. So in this design, there are three main clocks. One will be the PCI clock, sys clock, SDRAM clock. There are three clocks and it is having the timing period. Nothing but a frequency will be given. That frequency will be converted into time, right? Because you need the clock for the time, right? So it will be given in the period. In the period, it will be having the positive pulse as well as the negative pulse. That will be having the 15 nanoseconds. So all the timing, right? The timing units, and it will be given in your library file. Timing will be in the form of nanoseconds. Your voltage will be in the form of millivolts. Capacitance will be in the form of microfarad or the nanofarad, picofarad. Most of the times it will be in the picofarad. And in the power will be in the milliwatts. All the timing units will be given in the, just a minute. All the timing units, all the units will be given in your library file. So here there are three clocks that will be given in your STC file. So that's why they have defined the they have defined it in your STC file. So how they have defined, to define the clock, there is a command called as create clock. So when you are using the create underscore clock, the tool will create a clock with a period of 15 nanosecond. So you have to define for how much is the clock period. So that's why you have to give the hyphen period. How much is the period? It will be the 15 nanoseconds. So what should be the clock name? Hyphen name PCI underscore clock. That will be the clock. So for which port it has to give the clock. So from the top level engineers, nothing but those who will be working on the chip level, right? They will give the pin def. So they will define all your ports. How many ports, how many clocks? Sorry. Here, so for that PCI clock, P clock, it will connect to that PCI clock. Similarly, for the sys clock, it will creating this will be the clock name and this will be the port name. And after that, it's a create generated clock. The create generated clock is nothing but it will be from the taken from the divider circuit. We have seen in the digital electronics, right? The frequency divider circuit. How the frequency divider circuit, what is the functionality of the frequency divider circuit? How it will be there? Guys, frequency divider circuit. Digital electronics. What is frequency divider circuit?
Frequency digital circuit is in the digital, digital systems.
Yeah, this is what is that frequency divider circuit? How it will operate?
To divide and drop the frequency of high frequency signal to get the lower.
Sorry,
High frequency signal to get the lower.
how it will generate? I'm asking that one.
By using the clock.
By using the which circuit?
Clock.
Toggling
Flip-flops.
the mode of flip-flops.
Flip-flops.
Which
Toggling the mode of flip-flops.
What happened? Like which flop? How it will be? What will be the frequency divider circuit?
By using flip-flops, ma'am.
Yeah, like it will be. You will be whatever it will be there. It will be on the flops only. How it will generate? We have already discussed in the digital electronics. Remember, like asynchronous counter, there is a D flop, the Q bar which will be connected to the D input, and you will take the output from the Q that will be given to the next flop, right? That Q is connected to the clock pin of the next flop.
Yes, ma'am.
Nothing but from the first flop you are generating the that will be taken as a clock for the next flop. Suppose for the first you will be having the, like, suppose consider that frequency for the first flop it is having the 100 megahertz, for the next it will be having the 50 megahertz. Why? Because it is dividing the frequency. So why do we need the frequency, like why do we need the generated clock here? Why? Because suppose consider that you have the 15th here, there are 3 clocks which will be giving as a 15 nanosecond, 8 nanosecond, and the 7.5 nanosecond. Suppose consider that for the few of the flops or the few of the designs that requires the 30 nanosecond. For that you can't take one more clock because you have already 3 clocks in your design, but you need the timing. But for particular module you need the like a 30 nanosecond as a clock period. So for that what you have to do, in using the frequency divider circuit, you can generate a clock of the 30 nanosecond, and that clock period is given to that particular module. So that's why we are using the generated clock. That will be that will be defined with the help of the create generated clock. This will be the command -source. So what is the source? Suppose consider that flop 1 of the output is connected to the flop 2. Nothing but the source will be the flop 1. Why? Because the output is connected to the clock of the flop 2. So source is nothing but from where you are taking. So I am taking the clock as a flop 1, right? So that will be the source. Here it's a multiply, and sometimes you can take it as a divide by 2, like divide by. And you are taking the name of that particular clock and the port. This is how to generate the clock. Next will be the input delay, output delay. So in the further we'll discuss about the what is the input delay, output delay. So here whatever the like input delay will be given, right? It is defined in the form of set input delay, set of output delay will be given in the output delay. So whenever you will be taking the delays, right, you will be having the two values. For each and everything, you will be having the two values. Nothing but one will be the maximum and other one will be the minimum delay. Why we are taking the maximum and the minimum delay? Why? Because we will take the worst as well as the best. You can't take the only one delay value. You have to take the worst value and the best value. So that's why we are taking the maximum and the minimum for all the delay values. And also it is having the set case analysis, set disable analysis, setup time, hold time, transition time, capacitance, all the information which will be given in the SDC. So and one more file will be the left file. It is nothing but the layout extract format. So once the PD is done, right, that will be the design will be given in the left format, which will be contain all the information, nothing but how many layers you have, how many wires you have, what are the resistance of that particular wire, what is the resistance of that particular net. All the information will be considered in the, it will be present in the left. Nothing but which layer, how many metal layer, which metal layer you have used for this one, what is the resistance of that one, what is the capacitance of that one. Because in order to calculate the timing, you guys need the RC value, nothing but the resistance on the capacitance. Based upon the resistance and the capacitance only, the tool will calculate the timing. So all the design information, it will be extracted in the form of left, that will be given. So I don't think here the left is present. Tomorrow I'll show, for example, left. And the def, you can't see the def. That will be the design extract format. Whatever the design it will be present, right, it will be taken. So the output, it will be in the timing report. It will be having all your timing information. We'll see that once whatever the present is. Like it will be having each and particular cell delay, whether it is timing is met or the violated, all the information will be presented in the timing report. By analyzing the timing report only, you will get to know, and based upon that, you will get insight. So, any doubt? These all are the information of the inputs and the outputs. So, I will give the real path of this one, so you guys can have a look of this one. So in this part, please don't do any. Why it is not coming? I think we can't take the copy of that one. Over. Wait. Has not copied itself. I don't think we can take a copy of this one. Okay, we can't take a copy of this one. Please make a note of it. You have to go to in the SPD10, create your own only one directory. In that, copy the PD_SB. PD_SB. Inside that, go to the labs_PT. Inside that, go to the PT. Inside that, reference scripts. Inside the scripts, you will be having the netlist as well as the STC file. Okay. Make a note of it. SPD10. Don't touch the original file. Copy the PD_SB in your own directory. Please, I request you, do not alter any of the files because this will be the original design. Okay. Copy the PD_SB in your own directory. I will update this PPT in the Google Drive. You can just go through the PPT. Any doubt? Any doubts? Any doubts in the input output? Please go through it because from tomorrow onwards, I will be asking the questions because STA is much needed for the PT. So go through each and everyone go through open the tool, go to the file, open the file and note down the commands. From the next, from tomorrow onwards, I will be giving the assignments that you have to execute it on the tool. Tomorrow I'll show, I will explain the things and I'll show you how to do on the tool. So as of now, any doubts? Go through the input files and understand the things. If you are, any doubts, if you got any doubts, make a note of it, and tomorrow we'll discuss about the doubts. Any doubts? No doubts? Okay, then see you tomorrow. Please join at the sharp 7 p.m.